at Melanopath.
Hello, this is Arnaud de la Fouchardiere from Lyon. In this video, which is going to be the first part of a series of 5 videos, I am going to introduce the basics of immunohistochemistry and melanocytic proliferations. The study of the immunophenotype, which means the expression of proteins by the tumor, is really central in the integrative diagnosis of melanocytic proliferations. Immunohistochemistry is a complex tool and is going to be about choosing the adapted antibody for your selected task. Among the different types of antibodies, we have melanocytic antibodies that recognize the melanocytes with some variety in the specificity and sensitivity. Here's a list of the most commonly used antibodies, and here an example of HMB45 showing the dendritic melanocytes here in the epidermis. And here's adapted from my friend Laurie Lowe, the variation and sensitivity. As we see, S100 protein is the most sensitive antibody to recognize melanocytes, and HMB45 is going to be the most specific antibody. Secondly, we have in the setting of molecular pathology some anomaly-specific antibodies. Here, for example, is NTRK1 specific antibody in a Spitz tumor. Here is a partial list of some of the antibodies that can be used in this setting. They will be detailed in another video. Otherwise, there are some antibodies that are used to do differential diagnosis or, for example, to assess intravascular expansion of the melanocytes. So what's really important, first of all, is you have to know your antibodies, which means you have to be knowledgeable of which cellular compartment is supposed to be stained. Sometimes it's going to be the cytoplasm, like here on this BRAF V600E specific antibody. Otherwise, it can be the nuclei with also a small cytoplasmic stain for SOX10. The cell membrane in the nuclei and the cytoplasm can all three be involved in this beta-catenin stain. Sometimes you will be looking for a nuclear loss. For example, for BAP1 here in this nest, all the nuclei have lost the BAP1 expression, with controls, of course, here in the epidermis. Another expression is cytoplasmic loss. You're going to look for PRKAR1 alpha loss here in this antibody, which is quite specific of pigmented epithelioid melanocytomas. Also, you have to know the type of staining. For example, for HAB45, you're going to expect this very granular type of stain. Otherwise, it can be a diffuse positivity, for example, here for ALK in this plexiform Spitz. And in some cases, you will have a weak intensity, but you have a completely negative background. And this is usually what you will have for example, this NRAS Q61R. You don't need more staining than this to call the case positive. And for example, for BRAF V600E, usually you will have some degree of background positivity, and you really expect your cells to be strongly positive in the cytoplasm to be retained as a positive stain. Here are some different types of patterns. You can have a diffuse positivity in all the cells. There can be a top-heavy gradient, or on the opposite, an inverted gradient, which is a bottom-heavy gradient. And you can have a mix of positive and negative cells that can be called mosaic or checkerboard type of pattern. And lastly, you can have a heterogeneous pattern in the cells. And some of the patterns can be specific for some entities. For example, if you have a diffuse instead of a top-heavy HMB45 stain, this is something that is expected in a cellular blue nevus or in a deep penetrating nevus. Another example is the loss of S100 expression in the blue nevus group. Another important thing is you have to know your internal controls, especially if you're expecting to assess a complete loss of some of the expression. Here you have the checkerboard positivity of P16 and a nice internal control in the pars recta of the sweat glands. The NTRK1 can have this golden dot control staining that will be found not only in the epidermis but also in vascular structures as well as negative melanocytes. Another thing you need to know is that the thresholds you're going to use, these are the ones that I use, for example, for proliferation index that can be assessed by Ki67 or MIB1, and usually thresholds will be 5, 10, and 20%. Usually above 20% is what you will find in melanomas. For P53, the thresholds I use are less than 5, between 5 and 50, and over 50 in the dermal melanocytes. This will be this type of strong positivity will be suggestive of a melanoma. And lastly, you need to be a critic about your technique, and you do not want to interpret your IHC at all costs. So sometimes the region of interest is missing because there has been too many recuts, or it has been scratched by the technician according to Murphy's Law. Also, there can be some technical imperfections. Sometimes you can use some double staining. One of the most frequent examples is Ki67 melan A, where you have a cytoplasmic stain of melan A in red and a nuclear stain in brown for the proliferation index. So here's an example. You have this mix of melanocytes and lymphocytes, and you have some trouble assessing the proliferation index. Here you can clearly see that most of the melan A positive cells do not have a stained nuclei, and all the stained nuclei do not have a surrounding positive cytoplasm. So these are mainly inflammatory cells that are in the cell cycle, and there is no real melanocytic proliferation in this case. Another important aspect is the choice to use a red chromogene. This will help you distinguish cells that are positive and cells that have melanin pigment like melanophages. So why perform IHC? We will see this more detailed in future videos. There are 4 reasons: to confirm melanocytic lineage, to visualize the melanocytes, to try to assess benign and malignant cases, and lastly, to perform molecular characterization. I hope you have enjoyed this video, and you can subscribe to be informed of the future updates and the 4 next parts on this immunohistochemistry studies in melanocytic tumors.